and especially general seekers of truth. In this video, we will do an estimation of the sine of 1/2, and we will extend on that and say and determine whether the actual value is greater than or less than our estimate. So one thing that we need to start out with is a point or a number that's very close to 1/2, of which we know the exact value for the sine. So we need to find like some number, sine of like a. Right? That's going to be really close to sine of 1/2. But we have to know the exact value. We have to know the exact value of sine of a. So it takes a little, but we need to know the exact value of this number. So it takes a little bit of experience over time, but in this case, we're going to use pi over 6. Okay. And the reason I'm picking pi over 6 is because pi over 6 is very close to 1/2. Without a calculator, I could still figure out what pi over 6, pi over 6 is about 1/2, because pi is like about 3, it's 3.1415, so pi over 6 is about 3 over 6, which is 1/2. Okay, so we're going to use that point, and we're going to find the tangent line, or at least the equation of the tangent line, at x equals pi over 6. So let's start out by getting our point. So our point shouldn't be too hard to do. We know that sine of pi over 6 coincidentally is equal to 1/2. Okay. Now don't confuse this with how I chose that that pi over 6 is approximately equal to 1/2. This is just a coincidence that the output of the sine function is also about 1/2. So this is our point, and to find our slope, we're going to need to take the derivative of f. And I'm sorry, I should say that we need to define f of x here as to equal sine of x. Right? You probably figured that out already, but I need to be crystal clear on that. So f prime of x is not too difficult. It's cosine of x. And f prime of pi over 6 is equal to the cosine of pi over 6, which is equal to the square root of 3 over 2. So this is our slope. Right? That's the slope of the tangent line of sine of x at x equals pi over 6. So the equation of our line is going to be y minus 1/2 is equal to the slope, root 3 over 2, times x minus pi over 6. And then we can rewrite that. Y is equal to root 3 over 2 times x minus pi over 6 plus 1/2. And then we are going to estimate, right? And we know that by estimating for x equals 1/2, all we have to do is say that we know that sine of 1/2 is going to be very close to y of 1/2. Because near the point of tangency, near x equals pi over 6, the line and the curve are almost equal to each other. So this is the basis of our estimation. So this is going to be equal to square root of 3 over 2 times 1/2 minus pi over 6. That's my pen. This software here is terrible. Minus pi over 6 plus 1/2. Okay. And the arithmetic here of all this is not that important at this time. We can work all of this out. We could actually use the previous problem to estimate the square root of 3. We have some estimations for pi. It's about 3.141529, right? And then we can work out all this arithmetic. This will be good enough for right now as our answer. What I really want to get to here is the actual value greater than or less than the real answer? And this is kind of amazing because we don't know what the real answer is. Even if you put this into a calculator, all you're really doing is estimating for an answer. But even without knowing what the answer is, we can tell whether or not the estimation is an overestimation or an underestimation in the following way. By checking for concavity. So to determine if it's an overestimation or an underestimation, what we're going to do is we're going to check concavity. Check concavity. Now, let's think a little bit more about why is it that concavity matters in this case. Check concavity. Well, if, say for example, you had a function that was concave down, then the tangent line would go above it, and in this case, this would be an overestimation. This case would be an overestimation. If you had a function that was concave up, then any tangent line would go under it. So this, in this case, would be an underestimation. So to determine whether or not we are overestimating or underestimating, all we have to do is check the concavity. And so to check the concavity for f of x equals sine, we take the derivative twice. We already know that the first derivative is equal to cosine of x. So to find the second derivative, we take the derivative of cosine. And that's going to give us negative sine. And we know that f double prime at this special point here, pi over 6, this will be negative sine of pi over 6, which turns out is going to be equal to negative 1/2. Excuse me, I said that poorly. It's not equal to sine of 1/2. It's going to be equal to negative sine of pi over 6 which is equal to negative 1/2. Which is clearly less than 0. So at pi over 6, the sine function is concave down. Therefore, this estimate here is going to be an overestimate. It's going to be an overestimate. So our guess here is going to be, I should put a hyphen in it, overestimate. Our guess right here, whatever this number turns out to be, it's going to be a little bit bigger than the true answer of sine of 1/2. So there you have it, an extension on the estimation using a tangent line, where we're not just estimating, we can also try to figure out whether it is an overestimate or an underestimate. Thank you for watching, and have a great